Hello everybody, welcome to this week's video. The objective for today is going to continue building up from those sounds that we put inside of our engines in week one. In specific, we're going to work on specialization, trying to measure and create behaviors to understand where a sound is coming from and an audio source is, how it is behaving within the scene. Then we're going to touch on attenuations, the use of attenuation curves and filters that you can use utilizing the same patterns. Then we're going to go into profiling and how to measure or understand the behaviors of our sound sources within the engine from Wwise. And then finally, we're going to check how to trigger an audio file or an event utilizing the engine and Wwise. So that's going to be our process for today. We're going to start with trying to review the process on where we were last week. So within our Unity scene, we had left it looking more or less like this. This is our character controller, and we have placed an audio file inside. Let me make this bigger. If I centralize this, close that window. We had placed our audio here and we had selected orientation so that there was a difference in the way we could hear the audio depending on what direction we were looking for, but that was pretty much it. So first thing that we're gonna do in our Wwise project is apply an attenuation curve. An attenuation curve is going to measure our the changes that we can apply to an audio source configuration in reference to distance. So in the closest that you are to the object, the sound is going to play with the original configuration, and then we can create changes in a specific in attenuations is how what volume changes over a distance. So we're gonna touch on that configuration and see well, first of all, how to do that, because that will help us create sources that sound much more realistic. The farther away that we are from there, the least that we can hear from them. And we're going to start with that. So we're going to jump into our Wwise scene where we left it. First, we're going to go into the designer layout. And from here, we have, of course, our audio that we had input last time. There are a couple of changes that I want to do. So first of all, if I hear it, and when we were playing around with it last class, I don't think that the volume was like necessarily the greatest, so I'm gonna raise the volume a little bit. I'm gonna put it in 10. That is a lot better than what we need. The second thing is that because this is a continuous sound that is going to be playing while I'm in the scene, I'm also going to enable a loop here at the bottom right that is going to continue playing the sound. But because it is going to be looping over time, even though the sound is pretty, well, is more than a minute long, I also need to check how it plays with itself. So when the sound ends, how it goes back to the beginning as part of the loop. For that, we're going to do a little bit of a fade in, fade out. I'm going to check how it sounds here at the end. And you see that there's like a small click there because the transition is not necessarily too solid. So I'm going to cut here at the end when it starts to fade out. I'm going to do a really tiny fade in. Let me control and use my wheel to make that fairly small. Perfect. And then we still can hear the click, but I can look for a moment in the sound wave where we have something similar, a bit of an uptick. So I could cut that point in the beginning and put it like around here. You can see how that sounds. So that sounds pretty good, but we still have the problem that it is the clip is no longer there, but we can definitely hear it going back to 0 and going back again. So I'm gonna make these fading a lot shorter so that it feels part of the configuration. I'm gonna do the same thing here, make it a little bit smaller. Yeah, that feels a little bit better. We're in theory not going to be listening to that a lot more, but the clipping is no longer there, and we can probably hear the whole sound and then come back to it, and that's not going to be a problem. Perfect. Now that my sound is ready, I'm going to start managing the attenuation. So how do we do attenuation? Well, there are a couple of ways that we can manage that. The one that I'm going to do right now has to do with the specific configuration of the sound. I'm going to go here in my right pane, and I'm going to click on all. In here, we are going to see all of the different things that you can configure for this audio source. In specific, the one that I'm looking for is this positioning one. Because I know that that's where it is. I don't necessarily have to keep there. I'm just going to click here on positioning because it's where I'm going to find it. But you could just go to all and look for it. But in positioning, I'm going to here check for attenuation. You'll see that an attenuation is enabled, but there is no configuration, no attenuation made. That's the first thing that we're going to do. We're going to create a new attenuation. I'm going to put it a name. Let's name this box attenuation. Perfect. And we are going to create a new one inside of our default work unit. Now you'll see that we have this new pane that appears here at the bottom, and that is going to be the configuration of the box attenuation. This window is a little uncomfortable for me because everything is like down here, and we're going to be playing a lot with it right now. So I'm going to go back to contents on this space, and I'm going to double click on our box attenuation so that we can go to the full panel. Now, as you can see here on the left pane, when I jump into the box attenuation, it went into a different tab. I went from the audio tab, in which I had the digital horror sound, into the share sets tab that contains the box attenuation. Both are fine for us to try to access them. There's also these two tabs here at the top that we can try to navigate between them. The effect is the same. But now I have this curve, this graph that says it measures volume and then distance. So the maximum volume, which is 0, we're actually tracking a descent, is going to be when there is no distance between the object and the user. And then the lowest amount of volume is with the maximum distance. In this case, that is 100. Now, this value is going to change a little bit. I'm going to set it as 2 different numbers because both engines, Unity and Unreal, are going to use different measurements. So if you see this number change a little bit as the tutorials move on, is because the measurements for Unreal are going to be in centimeters and the measurements in Unity are going to be in meters. The difference is going to be in a matter of 100. If you check this and the graphic measures that we will do in a moment, the difference is are values in reference of 100. So a measurement of 10 in Unity will be a measurement of 1,000 in Unreal. Disclaimer. So that's where we are going to move forward from. How does the attenuation curve work? Well, we can actually play the sound and check it out. So I'm listening now to the sound, and if I click here on our graph and I start to go farther away, I can hear the difference that it's going to have or as distance increases. With the object closer to 0 being a lot louder than when it is closer to 1,000 in this moment. Now, next thing that we can try to do is that maybe this progression that is very linear is not the one that you're looking for. We can right click on the curve and change the way that that curve is made. We can see that we can make it like an exponential curve that will make the louder sound a lot more present and then have a more drastic drop on the tail end. We can make it an S curve, which is going to have like a little bit of a sustain and then drop and then stay lower. We can also do a logarithmic curve that is going to have like a larger drop and then go back to 0 like it was a slide. So we still have some noise over here. But that's it. That's honestly all that we need to do. I'm going to leave it here in the logarithmic curve. I think that this is pretty good. I'm going to go back into my digital horror sound, and now we can see that the box attenuation is configured here and the distance scaling is perfect. So that's that. I'm going to save, go into my sound banks, then generate checked, make sure that everything is generated and good. You see that it is pulsating and generating again. And then that's that. So now the next thing is going to be jumping into the engine and checking how this works. So now from the engine, we need to try to check how to visualize that information. So let's see how it behaves. First of all, let's just play the game. So I'm gonna walk into the scene, and you see that immediately there's a big difference. I cannot hear the sound as soon as I enter, but then if I walk around, you'll see that it becomes louder and louder the closer that I am to the source. That the configuration still behaves the same, so if I am looking to one direction or the other, I am going to hear it more from that side. But if I step away, it will just go lower and lower until it's no longer there. Perfect. Now, there are a couple of things that become immediately apparent issues. First things first is how do you know how close you should be, especially because deciding where a space is can be really challenging. So the thing to do, first of all, would be to try to visualize that space. So we have an idea more or less of how many... what is that? Okay. We have an idea about how many how big a space is within the game, but the measurement that we're making from Wwise is based on real life measurements, right? We're doing an attenuation curve from 0 to 10 meters, and that's the configuration that we have. So knowing how much 10 meters are within the game is kind of difficult. There are a couple of ways of knowing how much that is. Unity works in a squared system, measured system, in which each of these squares that are part of the base build are going to be a meter squared. But that is still kind of difficult information to try to parse. So luckily, Wwise comes with a pre-built method option that allows us to look at that information. That is going to take the form of, if you go a little bit lower, the attenuation sphere. I'm going to click here on the attenuation sphere, and it's going to click on all events. Here inside all events, it's going to show me what the attenuation sphere is. This is going to be the sphere in which the attenuation curve is taking place. Now, this is a little bit deceptive in the sense that, of course, similarly to how it happens with lights, the attenuation curve is going from a maximum distance to a minimum distance, right? So the closer that you are to that outer edge, this more close to complete silence that we are going to have for our source. So that's why, even though technically speaking the player starts the game within the sphere, we can barely hear anything. So the problem thing becomes here that we should assume that if our attenuation curve goes from a maximum space to like 0, that closer to the outer edges of this visualization is also going to be close to, if not 0, right? So the actual audible section is going to be closer to the space, the source, and then depending on what the configuration is, this attenuation sphere is more of a visual space for you to know what the maximum values of that distance is and what is being touched from that procedure. Now, I'm going to turn them off. Now that we have a usable attenuation curve, we are going to change the values that utilize that attenuation curve so that we can add or increase the characterization, I guess that you could say, of those audio sources that we're putting within our scene. The first thing that we're going to do is we're going to add a low-pass filter. Low-pass filter, as we mentioned in class, is going to allow for higher frequencies to be cut off from the audio source the farther away that you are from the distance, because as we mentioned in class, lower frequencies travel a larger distance than higher frequencies. So we're going to jump into our into Wwise, and we're going to add a low-pass filter configuration to our attenuation curves. Within Wwise, it's going to be really simple. We can do this from a couple of times. If you go into audio, and well, let me first change the layouts. We could go to our audio, and then down here we could select attenuation and do all of the configurations from here. However, the thing that I'm going to do is I'm going to go into my share sets, and then double click on the box attenuation so that we can see it here on front. I'm gonna select the low pass filter. You'll see that nothing appears on screen, and then I'm gonna change it to custom. In custom, we're gonna see it first of all that it's added. If we select control, select the volume, we'll see both of them working at the same time. And if I play the sound, we'll see how it changes over time, over distance, the same way that the volume one does. If we put it here, for example, it's a little difficult, but you can hear how the frequencies that are still present are basically only the lower ones, which are the ones that are being allowed by the low pass filter. We can make this a little bit more noticeable. I'm going to change this to, let's say, an exponential curve, so that cut here feels a lot more easy to hear. We can also do that by, for example, turning off the volume settings. And if I just select the low pass filter, let me stop the sound one more time. Custom, and then the low pass filter, and then the low pass filter, which is going to be custom. Yeah, there we go. We can hear these changes a lot more noticeably. How here, for example, only the lower frequencies are present, while here we see more of that whoosh on top. This filter, of course, let me pause it. This filter, of course, is filtering things in a percentage. At 0 distance, none of the frequencies are filtered, and the closer that you are to the max distance, the more frequencies are going to be filtered. That means that at 80% of the distance, only 20% of the frequencies, the lower 20% of the frequencies, are passing through. That means that by the time that we get to 100, you can only hear like the whisper of the lower frequencies. They are technically not changing in volume, but when we get to 100, no extra frequencies are passing through. We could make it then so that the last point changes a little bit, so that we always have a presence of lower frequencies, but they should be, I would say that at least cutting it at 80 is the lowest that I would go down. So that like by the maximum distance, when we are closer and closer to silence, the presence is like only the lowest of the frequencies. We're gonna add the curve for volume one more time, and then we'll see how it sounds. Yeah, you can still hear a lot of the lower frequencies even though you're farther away, and that's the effect that we're looking for. Let's save, go back to our layouts, generate checked. Let's see how that sounds on engine. So in Unity, we're gonna do the exact same process. Let's click play, and let's close this, have the game, and you can still hear some of those things. Let's see if we can update the browser, generate the sound banks, make sure that we have it correctly. Let's play it one more time. Okay, so in this aspect, it's a little difficult to really recognize if the file is changing the way that we want. One thing that we can do to try to see if the effect is more permanent is going to be changing the curve the same way that we did, like turning off the volume sphere, but the configuration should be the same. So let's say this low pass filter stays custom. Go to the sound banks, generate them checked, go back into Unity, and from Unity, I fetch this thing. Let's play it. Y en este momento, in this moment, we should only have them here. So volume is right now technically not going down. So the lower frequencies are still going to be present outside of that space. We can hear that only those lowest of lowest frequencies are still present, but the volume is still static, which means that even outside of what would be our attenuation sphere, we can still listen to them. Let's turn the volume back on, and then let's move to the next thing, which is going to be cone attenuation. So the next thing that we're going to cover is cone attenuation. Cone attenuation is going to allow our source to behave a little closer to our sources, because we make sounds again around us, but we are not an omnidirectional source. We are not making the same volume of sound in all of the different directions. That directionality allows us to listen a lot more directly if we're talking in front of us than it would be if a person was listening to us while they are behind us. So by adding a cone attenuation, we can try to put a lot of that directionality within the configuration of our sources, and it's going to allow for sounds to be heard in the way that you expect them to, more, well, like you would, I guess. So the only thing that I need to do to create a cone attenuation is going in here inside of my designer layout back to the attenuation configuration. Once again, I can do that by, like, for example, double clicking on my box attenuation configuration. From within here, you'll see here at the bottom right that we have a cone preview attenuation mode. I can access cone use, and this will make available an extra sort of configuration that will allow me to get the cone attenuation and value that orientation that we were talking about. If I play here, you'll see that I have an extra control that allows me to select not only how it is measuring distance with the outer edges of that circle, but also how it works in that initial cone that is directly in front, that is being affected by directly my source, and then on the sides, and then on the back. I can modify that attenuation by a cone max attenuation. I think that this by default is in -8. Which is the amount that is reduced, but I'm putting it on -12 so that, oh my god, so that it can be a little more readable. We can also affect how that outer edge, like how much of that sound is being affected by the direct distance, and then how much of that extra that is still listenable, but it's not going to be as attenuated, affects. So we can hear how that sound changes. For example, over here we have not that much of a change in distance, but we already hear the changes in sound. As in here, it's still direct and pretty loud. Here is significantly less loud, and here is a lot less loud. All of that in the max attenuation, which would be here at the outer edge, would be affected by the max cone attenuation. I'm just gonna close those angles a little bit so that they are a little bit more recognizable inside of our engine. Now let's just stop this, go to my sound banks, generate checked, and then we can go back to our Unity scene. Now in here, the thing that I'm gonna do is I'm gonna send this back, and this will allow us to play a little bit with the thing. Let's go into the game. You can see that even though we're close now, because we're behind, the volume drops a lot. Let me send it back. Here is super loud. Then it becomes less loud as we move forward. Let me make actually that sound a little bit higher. Let's make this like 12. Save, soundbar, generate soundbars. Let me reset this because it's not on the same. Update, play. The same thing. Fairly loud, and then if we move kind of back, it's not loud at all. Perfect. So that is cone attenuation. That gives us an orientation payoff for our configuration of the attenuation curve. So next thing that I want to discuss is a couple of acknowledgements in relation to Wwise. The first one has to do with how sources are configured and how the audio files we are putting in those audio sources are being utilized. as we mentioned before, most of the time when we are jumping into Wise, we're going to be adding either mono or stereo files into our audio sources. But in this particular case, or if for any stereo files, we're going to continue hearing those files only as mono, as long as this 3D specialization is the same. So let me turn this up so we can go here. I'm gonna go into positioning. Okay, so we have enabled our 3D, our listener relative routing, but the 3D specialization is only made in based on our position. If we set this in position and orientation, or we turn it off, we're going to be listening to the file as it comes in, basically as a stereo signal. But that stereo signal is going to be behaving as mono value in the sense that it's going to be sending things at the same. If I play this sound here, you're going to see how the behavior of both of these lines is going to go higher, in the sense they're going to be different. But if I turn it back into position, you'll see how they equalize and become the same behavior. If I value it for position and orientation, it's going to simplify it itself a little bit, but it's going to allow me to pan or value the 3D mix so that if it is into 0, we're going to have more of the 3D imagery, 3D information, the fact that these two channels are different into the mix, and the closer that it is to 100, the more that they're going to be equalized into themselves. Now, of course, a position information is the thing that allows us to hear more from one direction to the other, but they are going to be one direction to the other, assuming that the source is coming from the same location. Because of computing needs, unless you plan to take advantage of the fact that both of those channels are giving different information, I would recommend you to keep the position as is. But if not, the position and orientation value is there, and you can utilize the 3D mix to benefit as much as you want from that information. Now, the second thing that I want to try to add on to has to do with the emitter configuration. You'll see here at the bottom that we have an additional 3D position value. If you wanted to, you could select here an emitter position automation. We can edit that, and it's going to give us an extra window. We saw a little bit of an example about this window in class, but it's going to allow us to change how the emitter relates to space, especially in relation to the player's position. So let's add another, a couple of points. Let's add like 3. Let's make this second one here at the left. Let's make this third one here at the right. This will then, every time that I play the source, give me a different point from which the sound is sounding. Let me make that a little bit more relevant. Because you can barely hear it there. Is it because of the distance? Interesting. What's happening here? Is it because the attenuation curve is made there? Yeah, there we go. Let me change the values one more time. Yeah. So every time that we select a new one, we see that it's playing a different point. You can add all of these emission configurations, and if we save them and put them into our sound bank, they are going to follow that requisite. So every time they're going to play one of these 3 in sequence. We can change that. Instead of being a sequence, select it at random, and then instead of selecting one after the other, is going to put them in any random selection. We can also change the value so that instead of being just one point, we can change or add multiple other points to that same travel. So let's say that we have like this big circle, it goes from one to the other, and if I play this one, you'll hear how that sound is going farther away and coming back. Let me make that more apparent by turning off the attenuation. So, is it none? Yeah. We can hear how it is like traveling around. We can hear it like going all the way. Now, that option is there, but it should be said that it will depend on like what they're using it for. If you have like, I don't know, a pigeon or something, like a different source that is going to need for you to plan the different positions that they're coming from, or you're going for a vibe that has a source that can be placed in multiple spaces. So let's say that you're putting birds on trees and you don't want them to always come from the same space, so you change the position values a little bit. All of those things are going to be very beneficial from this system. In our current examples, I'm just going to leave them as is. The emitter is going to stay in position, and we're going to reactivate our attenuation. Let's go to the box attenuation. All of these values, very relevant, really important tools for you to try to have, and are there for you to utilize if you need them. The next thing that we're going to take a look is the profiler. The profiler is going to be our stepping point to make sure that everything that we're putting inside of our Wwise project works exactly as we need to. It's relatively simple, but it is a connection that allows Unity and Wwise to work together to try to measure what events or what systems that are being introduced through Wwise are working in every given scene every time that it plays. And configuring it is fairly easy. As we mentioned before, a lot of the things that a lot of the problems that arise from doing this or utilizing this sort of software is the idea that like maybe things are not working the way that you want them to. So the profiler is a really good tool to try to see specifically what is working and what isn't and why. So let's take a look at how we can check it. First of all, if you go into layouts and you go into your profiler window, you'll see that it opens up new layout. Here at the top, there is the option to connect to a remote platform. And when you select it, it's going to show you all of the systems that are being used in the time. In this moment, our application is going to be the Unity editor, and I can connect to the system so that we can track that transition over a period of time. I will see that this is live and the live data is being shared, and we can stop the capture at any time or reconnect it here. Now, here is a bit of a disclaimer. There is a chance, depending on how you're making the transition, that when we go back to Unity and we play that game, it's going to break. So we're going to, let's put Unity here so that we can check that value in real time. I'm going to put the game layout here. You'll see that it is already detecting information because we're inside the application. If I press play, one of two things can happen. Sorry, I forgot to reload the thing. So the game is already playing, and we hear the sounds from our game as we expected, but no information is appearing inside the profiler. We see that the connection disconnected. This can happen every once in a while, especially if we're working with free resources, but we can connect it back in the middle of play, and it will stay connected even after you finish play. So we'll see that it connected back one more time, and we see here that there is the event connected. If I go back into Unity and I continue playing the game, you'll see that extra information appears. We see at the top of the graph how the audio is being placed. I can continue playing, so let's do this one more time. I'm gonna jump on the other side, do a bit of a turnaround. I'm gonna walk back out and stop this. And you see here in our profiler multiple things. So for example, we have that the event was triggered at the beginning, but also we have that the event stopped, that the event finished, and also what the information from which bank is being loaded and unloaded, and how that behavior went. I also can walk into the CPU totals. You see here that there is a big jump the moment that it started, but also everything else is kind of low. I also can check the voice configuration to see where it was coming from. So for example, in this case, the sound was coming from this specific object. This is the sound that was playing. This was the listener, which is the thing attached to the camera. I can also see the output peaks. So here were the moments at the bottom that had the most amount of quote-unquote volume, amplitude, and we can see how they change over time. It's all pretty good. We also can check how the behavior had on listeners, and there's like a lot of extra information. I would suggest you to check. It's also Good because we can see that change over a period of time. Also there at the top, we can see what volume was being referenced here at any given time of the recording. And this analysis then becomes really useful to try to track specifically what can be going on for your scene. So the next thing that we're going to work a little bit on is going to be how to change a little bit the information that we have for the behavior of that source from within Unity. This is going to be relatively simple, especially because we're just going to be interacting with the same type of system that we already had, but just utilizing Unity. A problem that has arisen, if you have been paying attention, is the fact that this sorry, I have an error there that is kind of weird. Okay, it's that this source that we've been playing around with, does not have like the sound that is going to be playing here is going to continue playing even when we are outside of the playing area. If we make the attenuation spheres available again, we'll see that this, of course, is the sphere in which the listener's behavior is going to change, but the sound is going to continue playing forever. We can then try to create a trigger space in which the sound is going to play when we walk in it, more or less of the size of the size of the sphere, or that it isn't. We can sorry, and that plays and stops when we walk in, and it stops when we leave. How do we do it? So we're going to do a couple of things. First things first. So first of all, the thing that we're gonna do is we're gonna create an empty game object. That game object is going to contain our new trigger area that we're gonna be playing around with. It's not gonna be that one. So let me just, I could deactivate this object. Yeah, let's deactivate this AK ambient. Let's not show it. I'm gonna go back to our project. Let's go into our assets. And in here, there are a bunch of starting assets that are going to be relevant. I'm going to go into the prefabs and let's grab one of the cubes. That cube is going to be around here. Now, interesting. So for that cube, we're gonna put it into our empty game object, and that empty game object is going to be our original sound cube. Cool. So in that sound cube, we're gonna play around with for a little bit. Sorry, I ran into a bit of an error because I turned off the AK game object, and that made my console scream because they didn't like the idea that the AK ambient was on and the other one wasn't. So neato. Okay. So we have here our original sound cube, and the original sound cube is going to contain the same configuration that we had made for our original cube. So in here, I'm gonna grab the original sound cube, and we're going to go ahead into our Wwise browser, look for our events, default work unit, and we have our play digital horror, and add it, add a rigid body, and then that's it. We have the same configuration that we had earlier. Now, from that, we can do the same thing and then show. Oh, sorry, that was my bad. As you can tell, I made a mistake here. So let me turn this off. What's happening? So the position of the original cube sound thing that I have is 0, 0, 0, but the box is farther away from that distance by quite a bit of margin. Let's say that this is 5, then 0.5 because that is the height, and then minus 15. I want this position to be the position of the game object, not of the cube. So I'm going to right click on position, copy those values, go into the original sound cube, paste those values, and then go to the box and go 0, 0, 0. That way, it is centered in the same position as the original sound cube. Now, the original sound cube, if I select once again the attenuation curve, I could do it on all events and it will appear both of the ones that I have available. I'm just going to do current event only, and we see that it exists on that position. Let's play that value. And we should be able to hear that same the same configuration that we did from the other side. So I'm gonna go into the game, Let's walk inside. We can hear that sound. It is working the same way. Perfect. So now, the objective here is going to be creating an area in which the sound is going to turn on when we walk in and turn off when we walk out. How do we do it? Well, luckily for us, Wwise already comes with a lot of systems that are built for that. In a specific, you'll see that here on AK Ambient, we have a trigger on value. I can select that and then change it from start, which will be the thing that we are utilizing right now. Let me select it again. Start to something more desirable what we need, like AK trigger enter. I'm gonna select AK trigger enter, but I also need to deselect start, because if not, it's going to have both of them at the same time, and it's gonna turn on start and on AK trigger enter, whatever happens first. So I'm gonna deselect start and then allow AK trigger enter as our only AK ambient for the sound to play. That is going to be in relation to our play digital horror event. Now that means that we have, if something enters the trigger area, it's going to work. Now, however, we need to make available that AK trigger enter as our condition. For that, we're gonna go into the components and we're gonna look for an AK trigger enter. That's gonna be our area. Or like our condition, and when this condition is met, when the object enters the area, we can use that. Now we need to select what is the trigger object that is going to walk into that area, so that like it's only for that. And we just need to go ahead and find our player object. Here is the player capsule. We can go down here. The player capsule is going to the trigger object, and now when the player capsule walks into the trigger area, then this will work. Now, so now the final thing that we actually need is that area in which the trigger is going to happen. For that, we're going to go back into our spaces and we're going to look for not a trigger sphere, but a sphere collider. The function immediately works in relation to that area if we turn it on as an is trigger. So let's increase the radius a little bit. And then for this, we can actually utilize the attenuation sphere to make it work. So I'm going to turn it as a current event only. And let's keep it smaller than what it actually is. So let's keep it like 6. That way we are going to hear the drop off immediately. Usually you would want the trigger sphere to be bigger, but for this effect, let's just keep it at that. So now we should be, or have the option that if we walk in for our game, let's see. So here I should already be in the area in which I can actually hear it, but it should turn on fairly dramatically as soon as I walk closer. We got it there. So it is turning on when I trigger it. We can also, of course, check that information from our profiler. So let me go back into Wwise, go into our profiler layout. Let's create another connection. Select it, connect. Perfect. And now let's go into Wwise. I may need to run this again. Let's make the play area smaller so that I make sure it has it disconnected. Let me connect it again. Connected. I can also reconnect pressing this button, but I didn't. And then we walk in. We have the thing. Let's stop this here. And then if I minimize this, you'll see that we got a action triggered when the event played. That is happening specifically when we touched on the cube. We can make that a little bit more obvious. Let's do it the same process one more time. Great. So let's go into Unity, play this game. Make it a little bit smaller. Just keep it like there. Reconnect. And then once we're here, actually, let me make it one more time. Let's do it like this. That way we can see the files. So if I walk inside here, boom, we see that the event was triggered and the play immediately happened. Perfect. Now, the problem that you probably realize immediately is the fact that it's really good and we can walk into the area and now it plays, but if we leave that area, so let's walk in, it plays, really cool, but then when we leave the area, it is still going to be playing, right? There's nothing stopping the sound. So the next thing will be to add a value that does that. This part is gonna be really, really simple because we already have the configuration for the ambient sound made. However, we need another event. So I'm gonna go here back into my designer layout. I'm gonna right click on my audio source. I'm gonna create a new event. This is going to be a stop event. Stop. I go back into my events. I have this here. Now I'm gonna go into my sound bank, grab that stop event, put it into my sound bank, generate the checked ones. And now I should have that event if I update here into my Wwise browser. Events, here is the stop event from the Play Digital Horror. I can grab that original sound cube that I had, grab that stop event, and then drag it into my scene. Now, same thing will happen here. I need to change this from trigger on to, we're gonna need to move our configuration of the AK ambient from start to something else. I'm gonna deselect start. Sorry. And I'm going to put it on trigger exit. This is going to be our call for this so that when we come in, the sound plays, and when we come out, the sound stops. So I have selected this, but we also need to configure another AK trigger object. So I'm gonna look for an AK trigger exit. Let me put that a little higher so that it's readable. There we go. AK trigger exit also needs to recognize the player capsule. So I'm gonna grab the player capsule, put it in there. And now we should be able to hear the cutoff really, really nicely. We have both of those options in place. Let's walk from here and then boom, play, and then off. Do you see that it disconnects immediately? Let's do a quick test utilizing the profiler. Let's go back, profiler, remake the connection. Okay, we have it running. We try it one more time. So play, stop. Actually, let's do the same thing that we're doing. Let me put that on the side window. So play, stop, play, stop, play, stop. Fantastic. Let me stop the game. And then we can see in all of these spaces when that happened. We also see how they change over a period of time, what is being active at that time. You see that every time that it plays, the specific sound is going to make a line from where it was and where it was sounding. And then when it stops, it disappears from this area. Perfect. Now, of course, one thing that is going to be different here is that our configuration for this cube is right now, like the sphere is smaller than the attenuation sphere that we have. If we make, where is it? So let's put this here as a current event only. You can see that this is still bigger. In reality, we would like the sphere to be bigger than that. We know that the trigger area is 10 meters. So if we just make this 11, you'll see that the area of the trigger sphere is going to be slightly larger than the other one. Actually, we can make it like even smaller, like something like 10.5, because we know that this is around 10. And that already creates an area in which the sound is going to be loaded and then slightly fade in as much as we need it to for our game. Now, last thing that I'm going to do is, I don't think that we're going to utilize this sound again. So I'm just going to delete and remove these components so that they don't generate more errors as we move forward. And all of the sounds that we have applied here are just attached to this one object, which is the original sound cube. Let me stop showing the attenuation sphere. And now we have this object here that I can move around and try to utilize as reference for objects moving forward. Now, this is all that I wanted to have for this week. please, if you have any questions, one more time, make sure to communicate with me. Send me an email if you need to, and I'll see you next week. Thank you so much.